Hey everyone, welcome back. In the last video, we have seen how to compute loss for a given question answer pair. So now let's assume we have our first desired question answer pair. So for this desired question answer pair, we anticipate our actual reward is greater than our average reward. We anticipate that and we consider this as our equation. So now, while computing this equation, let's assume while calculating actual z and actual z naught, you actually found out that z value is less than z naught, right? Just because it is desired question answer pair, we have considered this. That's how we have to pick between both of these equations. So now we picked this for the right question answer pair. And after calculating z and z naught, you found like z is less than z naught. If z is less than z naught, my loss will be high. But ideally, what is my objective function? I have to reduce my loss. So in back propagation step, I update my weights in such a way that z will be greater than z naught, right? So that's how I do back propagation across different rows in the specific data set. This is how we train a data set using KTO optimization. There are lots of advantages of KTO optimization when compared to other human alignment techniques like DPO and PPO. The first one, which we have already seen, that generating a training dataset for KTO is much more simple when compared to PPO and DPO. Another important advantage is, let's quickly go back to our pipeline. As we know, for any conversational AI training process, we have three different components. So now if you use KTO optimization, you can replace both these steps with KTO only. KTO optimization internally will perform both of them. So this will reduce training time a lot. As per this research paper, it is mentioned that this property will hold true only for slightly larger models like Llama 13 billion model or Llama 30 billion model. The number of parameters should be slightly greater than 10 billions. Only then you can replace supervised fine-tuning stage and human alignment stage with the KTO stage. Right? That's very, very important. The next important advantages. So now let's assume the dataset that you have has lots of undesired examples and very few desired examples. In such case, you can balance this scenario using lambdas. Let's go back to our loss function. So now let's assume for every desired question answer pair, you have 10 undesired question answer pairs. If your dataset is imbalanced, something like this, how you can select lambda is lambda L will be equal to 1 and lambda G will be equal to 10. Right? We use lambda G for desired question answer pairs, right? So that's the reason we weigh more for lambda G. So this is how you balanced your imbalanced data set. So such kind of provision is not there in other optimization or other human alignment techniques like be it ORPO, be it IPO, be it PPO and DPO. You don't have such kind of technique to balance your imbalanced data set, especially in the human alignment stages. So KTO is very important from that aspect as well. So now if you are following my previous series, which is text to SQL series, right? So there we have built a complete end-to-end multi-agent system using LangGraph. So at the end of the series, I very clearly mentioned that that's not the final version of the text to SQL agent. We need to iteratively optimize and improve the agent. So one way to optimize the agent is by using KTO optimization. If you remember that video, you will be having a router agent. Router agent will route the request to different domain specific agents, right? So now these domain specific agents are very heavy, right? They have lots of components within them. This is also taking a lot of time to process the input and share the SQL output. So that's the reason I've already mentioned in that series that once you accumulate a recent amount of data or decent amount of data, for example, let's say for a given question, this is the SQL query generated by your text to SQL agent. For question 2, it has generated SQL query 2. For question 3, it has generated SQL query 3. So now let your development team or any other data analyst label this data. Let's say you have accumulated some 4,000 to 5,000 question and SQL query pairs based on a text to SQL agent. So let an LLM or an analyst label this data set. So for this question, is this right or not? For this question, it is right or not. If it is wrong, just put 0 against this. So now if you have a data set, something like this, and this is very similar to the data set that we've seen over here. So now we can run a KTO optimizer on top of this data set, right? So now likewise, if you run KTO optimizer on top of such kind of data sets, we can slowly try to replace our agents one after the other, right? So this is one way to do optimization. So if you don't do KTO optimization, generally what happens is you need to do a supervised fine-tuning stage where you feed in the knowledge to the LLM. Once you do supervised fine-tuning stage, let's say if your model is still hallucinating, you need to employ techniques like DPO and everything. Rather than having this two-stage training process, you can employ single KTO process, right? It is much more efficient and time consuming. It is much more optimized when compared to the two-stage training process. So this is how you optimize our text-to-SQL agent, right? So also, there are a few choices that we have taken in this KTO optimization. The first one is our reward model. So if you carefully see, our reward model is very simple. It is log ratio of online probability for a given question answer pair divided by offline probability of a question answer pair. So now when you look at DPO, the reward model or the reward function over there is completely different, right? So again, if you go to PPO, the reward function there is completely different. So now this reward model differs from model to model or optimization algorithm to a different optimization algorithm. So I think pretty much for this series, if you really like this series, please like, share, and subscribe to my channel. Great. Thanks, everyone. See you in next series. Bye.